Okay, so good afternoon, everyone. So I will present my recent developments around deep physics projects. So I will skip the reminder since I've been presenting the project several times, but so that you can still have the slide if you want to have an overview of the project. So during the last STC, the state of the project was the project was just released, the previous XTC, and I spent a lot of time of designing examples, tutorials, and writing a documentation. And this was the roadmap that we defined 6 months ago. So as you can see, there is only one fully complete objective, and several that I started to tackle, but I will go through details. And so mainly my developments were around a new Python library, which is called SSD, that I also presented yesterday during the symposium. So the first part of my work was to develop and package and release this project. And the second part was to integrate the SSD features in DeepPhysX.
May I ask where?
Yeah.
I'm sorry. May I ask where is the SSD available? Because I was on the Mimesis GitHub.
Yeah, for now it is only on my GitHub, but I will
Okay.
transfer it to
Okay,
this
cool.
one. So yes, these are the motivations why we wanted to use so an SQL database in our workflow in DeepPhysX. In red, you have the previous data flow, and in blue, you have the one that we wanted to create to have in a nutshell, we wanted to make the data flow more efficient and more customizable so that we can use various training data types. For instance, to use various network architectures. So we decided to implement it in an external Python library, so the famous SSD package, because those are features that could be also interesting for people that are not doing deep learning. So this is why we created a new package. So here is the same slide as yesterday. So SSD is designed to provide solutions for storage data storage for your numerical simulations. You have two parts in the project. The first one is dedicated to pure data storage, and the second one is dedicated to visualization data storage and rendering. So it is more scientific rendering than beautiful rendering in Unity or something like that. So just a quick tool to have a visualization of your data, and you can replay it. You can have a visual if you render if you run your simulations with Python, etc. So these are the there is also a SOFA layer. So as I explained yesterday, there are some additional features with SOFA for this package. So these are the achievements that I checked for this SSD project. So having a stable version of the code for both packages. I designed also various examples and tutorials, write dedicated documentation, packaged the project and released it on pypy.org. And I also included the choice of the visualization library that we defined in the previous roadmap for this package, because now the visualization tool is directly implemented in SSD. So we wanted to extend the choice. Now we have only visualization under Vedo, which is an external Python library, but we wanted to give the choice of several visualization libraries. So I started to implement things in Open3D, but it is absolutely not ready for now. And the other part of my work was to integrate SSD features with DeepPhysX. So there were three main axes. The first one is to adapt the database layer for DeepPhysX. So how to init and synchronize the database with all the components of DeepPhysX. So all the simulations, if they are run in parallel, and the network, etc. So yeah, we had also to manage the connection from another process to this database, and also adapt the functionalities that we had previously with the previous dataset manager. We translated it in the new database process. Next, I had to change the whole data flow. So how the way to define your training data and the way to use it at the network level, and to make a lot of clean and to remove all the previous data flow that were not needed anymore. And finally, spend a lot of time to do tests to make sure that all the options that we have in DeepPhysX were still working with this new workflow. I updated the API, I updated all the sets of tutorials, etc. I also updated all the doc strings, and I'm currently updating the documentation. And once the documentation will be updated, I will be able to release the new version of DeepPhysX. And so for the next 6 months, I propose to still work on the unfinished tasks that we defined in the roadmap. The reason is that I will finish my contract on DeepPhysX in December, but I will still stay 2 additional years in the Mimesis team to work on new topics, so more on differentiable simulation stuff. But I will still be involved in DeepPhysX, so I still continue to reach the point that we defined previously. And so, yeah, to have a few words about differentiable simulation, I won't be able to give you that much details about what I will do and how much I will be involved with so far. But for now, Alban, who is a PhD student in the team, is starting to do some stuff with differentiable simulation. So basically, he takes the solvers and force field from SOFA and translate them in PyTorch so that all the operators are differentiable and so that he can do a differentiable simulation. So this I will start from this point, and I won't be able to give you some details for now, but maybe at the next STC I will be able to define a more precise roadmap around this topic.
That would be actually cool to get some feedback about even in between during those 6 months before the next STC to have an idea of if you have at some point what would be the amount of connection basically with SOFA. I was also curious. I forgot the point in the notes. Connection with Jim. But it would be I would be curious about the funding that has been used for that allowed like to cover this topic of
differentiable simulation.
Differentiable simulation. I'm just wondering where it has come from, but this we could really discuss that later. Okay. Derek?
Yeah, just one question regarding DeepPhysX. Is it right now? Is it cross-platform?
Yeah.
Totally. Okay.
I did not test it on Mac because I have none, but it's working perfectly on Windows and Ubuntu. So I guess on Mac OS it would be. But Stefan used DeepPhysX on his Mac, so yes, it is also tested. And as it is full Python, so that's it.
Okay, cool. Thanks a lot, Robin. And the connection with the future engineer at Defrost, that would be also a point where definitely when the guy arrives, for instance, Leo and Alex, as soon as you have the.
But now I think we have a better timing since DeepPhysX is now ready with these new features to deal with reinforcement learning. So I think the timing is better now than 6 months ago.
Okay, great, thanks. Is there any question or any remark? Not here, and yeah, there were people joining.
Maybe I can send the links to SSD so that you can have.
You mean the link towards the GitHub? Yeah, I already found it and added it in the documentation. I could have added actually here in the chat as well, but okay.
So there's also one point. There's still no license.
Yeah, this is a point we discussed a few days ago with Stefan.
The license of SSD, but is there and DeepPhysX? Okay, that was my point. Okay, also, and what's the conclusion more or less of this discussion about the license? Okay. Okay, LGPL. Okay.
We also wanted to. We have an idea to write a technical article, like
some kind of technical report or okay. Okay. Like really publication about that, or it would be would that be really a publication, or would that rather be like a technical report that would be written? Do you have an idea, or?
I think Stefan has 9 more publication.
Okay. 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 Cool. All right. Up. I'm gonna share my screen again. There we are. Before, so we moved. We covered basically all the topics from the V2212 roadmap. Just a reminder about the idea that we have plenty of jobs that can be actually be proposed, suggested, found, and so on. If you're curious, just never hesitate to just get in touch with us for any collaboration or directly open position to take in the community. Since we covered basically all the topics here, we come to the point where the idea is to define the V2306 roadmap. There should be actually very soon Stefan joining. I don't know if Christian is also back in the audience here. No, I don't see him. And the idea will be to, based on what has been actually already said so far, to select potential projects, and for each of them, suggest possibly like objectives, a set of objectives, realistic one for the next 6 months. And the idea is like really that people have to be active on it. If there is like, if it's just an idea, obviously this does not come to the roadmap, but the idea is to list all the possible topics that could evolve in the next 6 months and to and discuss them possibly this afternoon, and then add them on the official SOFA roadmap for the next 6 months. So review each project objective and decide. That will be by the end of this afternoon. So that was the few. I mean, that was the plans and I would say the topics that were raised this morning by the different people in the audience. And yeah, for what could be actually added for the roadmap, there is definitely, I think, work on SOFA Gym. So I think that's a topic that could be added to the roadmap. I don't know if Leo, maybe along with Alex, or I don't know with who you would like to set this up, but the idea would be to like set a list of tasks. But you already mentioned some of these tasks. I would guess this morning, if I take back again the notes of this morning, basically it would be mostly documentation efforts, and the second one would be working on the performances of SOFA Gym. If you have like more details about what kind of element, what kind of focus you would like to put on for the performances, do not hesitate to add it. Matrix assembly, I think this could be a point for wider discussion here, to see together, Alex, what would be the next steps. It was a bit linked to what you mentioned before, also Fred, for taking benefits in the constraint resolution. The fact that we have a pattern that could be reused, or at least exploit that if it did not change from a time step to another. And go towards like using the matrix assembly format that has been introduced by Alex. The BIM models, I think for BIM models, maybe we can set up a first set of objectives, but it might be like refined by Friday. I think Friday morning, as I said earlier, there will be a discussion focused on BIM adapter, especially. So I think here we need two things. We need the feedback for COSRA, the feedback from INSA to know which point he would actually like to push. There were already the feedback from Camille. Camille, are you around again?
I am, yes.
Cool. Just so I'm just saying that again, especially for you on Friday, if you are like available and you would be willing to participate to the discussion on BIM adapter. I think it could be cool. Like the idea would be how to basically make the simulation based on Timoshenko BIM theory more efficient, and also maybe close to a point that has been raised by François earlier, to also go towards some comparison between really BIM adapter, COSRA, and it's, you know, we are using a lot for endovascular simulation BIM adapter, but it would be nice to assess that it's the best option for performances, accuracy, and so on. So there will be this like 3-hour session on Friday from 9 to noon CET. So if you are available, it would be cool to have you in the loop. We would set up a link for that. Okay.
Yeah, definitely, sure.
There is a few other. So yeah, the tiering plugin that you implemented, I think it's released, but is that like completed and so on? Because I know you wanted to improve some. Yeah, okay. Because it could be like just, I don't know what you think, but just good to highlight it also in the roadmap, saying it's out, it's going to be like polished in the next months, but it's going to be released. It's not yet on the marketplace, right? I think. Okay. Just checking if I got that in my yeah, here. All right. So yeah, could be this. I think does not really require discussion for this afternoon, but it's cool to have it to keep it in mind. So I'll write it down. Collision detection using on GPU using LDI. So that's a topic that has been raised, but for the moment it's like pending a few legal points. So we'll see what we will do with this. Clearly, sorry.
I mean, it's compiling.
It's compiling, but not working, right?
I guess the example seems to be rewritten, but it's compiling on me. But just have to figure out legal point of view.
All right. So I'm not in the right window. There we are. So okay, so the question would be, what do you see as Alex? Are you available? Because we could maybe start with the topic of matrix assembly to see what kind of objectives or you know what would be the tasks you see as next steps for your work. Maybe there could be some connection, as we said, with a point raised by Fred. So I'm taking again here. Yeah, perfect. The notes that I had for you. Okay, because you wrote like future work, multi-threading, propagation, propagation of the API in plugins. Wow, it's especially in the Defrost plugin, obviously, but for SOFA, for changes in the core of SOFA would be more multi-threading and the management of interaction force fields, as we discussed earlier. Would you like to elaborate a bit on that, and like what would you see as next step then, even maybe further to those 2 points?
Yeah, so definitely the interaction force field would be the priority.
Okay.
And once it's done, the branches are most over, and it could be reviewed and eventually mailed. But I mean, after that, they could be more work, but it's not mandatory for
the integration, you mean?
Yeah, for the integration. So, for
And-
example, multi-threading is typically an example of it's like a bonus. It's not really a priority, and I don't think I will even start working on that. Maybe with the help of someone else, an intern or something, or another engineer. But I don't think I will have the time to spend on it.
So for the next 6 months, you think that already those 2 points would be like enough or too much? That's what you...
No. The interaction force field must work.
Okay.
So
okay.
it is definitely the first priority. Multi-threading is not a priority.
Okay. So here it would be maybe first to define the basically the approach format to interaction force field.
So it's not really, as François said this morning, it applies also on multi-mapping. So it's not really interaction force field. It's more when you have a component that contributes to the matrix, but with multiple associated mechanical objects. And some coupling terms.
Okay.
I've got also like one future line of maybe possible interest for you, Alex. It would be, I don't know if you have thought about also like when you express boundary conditions with basically matrix projection, like the it's I know that it's something which was also attempted by Christian in a way, and I re-implemented like I think a similar way of doing that, like essentially like for beams. I don't know if you're familiar like with there is two concepts that exist like between degrees of freedom and nodes, I think, in the beam adapter plugin. And essentially there is a way like to say that if you wanted to rigidify parts of a beam model, you could describe that basically as a matrix projection between the doves and the nodes. I mean, and essentially this mechanism can be expressed as well as using projective constraints, where you essentially are making if you have some doves which have a dependency between one another, you can sort of say that express this relationship with the projection of the mechanical matrix and the Jacobian matrix for the constraints and the right-hand side. And it's also something that could be done between different mechanical objects. So you would have to project maybe two matrices because one would be if one mechanical object basically expresses like the solution for another one, then it's essentially it's very, very similar to a mapping, but the only difference being that usually like the solution of your system is only expressed with as the state vectors of independent mechanical doves, and I think it's a good way to not change that actually. And here it's something where you have like one degrees of freedom which imposes its solution to another. So it's a generalized, actually, a fixed constraint in a way. But yeah, I don't know if it's something that you've discussed about with Christian. It's
no, I was not aware of this kind of things.
I mean, it's new stuff. It's not like something that is properly implemented currently in SOFA. But I know that it's essentially sometimes instead of using like a Lagrangian constraint with a Lagrange multiplier. If you know that for several degrees of freedom, you know the solution of your system because you have basically you want to say like mechanically the solution is provided by another mechanical object, then you need to project to make some projections like to reflect the fact that if you push or if you have an I don't know, a solicitation on a degrees of freedom which is going to be whose solution is going to be imposed by another one, then you need to transfer this contribution to other DOFs, and that requires essentially three things. It's projecting the right hand side to say like okay, the forces are going to be transferred directly to other DOFs, the Jacobian matrix, and also the mechanical matrices like the mass and the stiffness that needs to be also projected to the DOF that will actually be solved. So that's I don't know. It was something I wanted to raise as a potential topic of interest. I don't know, maybe I'm going in many directions, but it was
no, it's good to know.
No, but I know that it's something there has been a sort of in-house way of doing it in the particular case of beams, where actually this relationship is directly, I think, expressed somehow in some of the force fields in the beam adapter plugin, but maybe it has been refactored and removed. But I know that this mechanism is actually something that should have been or could have been expressed with the projective constraint API.
Okay, thanks. So the difficulty of this project is that there is always one case that is not supported or we didn't think about. So thanks for.
But right now it's really something where it's also not working well. I mean, in the current API, it's just it's and just it would be nice if we could have like all the different possibilities, like to express a relationship between DOFs and to get them all working well. And currently, the only thing that is working is usually Lagrange multiplier or fixed constraint, or because force fields they are not working if you use an implicit integrator where you need to have like the stiffness matrix assembled, and when it takes place on map DOFs. So this is what your proposal is actually solving. But it would be really cool, like to be able like to express all these different boundary conditions, like and to have them all working. So it's great.
Okay.
So would you guys see do not hesitate to add, in the pad, or I would say in the notes that I'm having here. I can again give you the link in the chat, but to add any of add any objectives that you'd like to add. Even like I was starting to decompose actually, Alex. The point of saying there is the need of managing these matrix contributions affecting several mechanical objects. Which means also that maybe there will be like pull request and integration of those changes and maybe tests that comes with it, and then make basically I don't know if we could have like examples highlighting that in the code. But if you see other like bullet points for things to like make sure that this priority objective, which is the multiple interactions possible between which can be here through the mappings that are well handled. That do not hesitate to complete what I just wrote.
You can add the propagation of the API through the software code base. So that could be done, but in a second time. So because there is the compatibility layer, it's not really the first priority. It's only the second one.
All right. I wanted to say we can also create like breakout rooms if some guys want to talk privately from one specific topic.
Do not and for instance, I did not create here in the notes. Yeah, you can see my screen, perfect. I did not create many like roadmap discussion like the documents where you would actually add the objectives and so on as we did before. So for instance, Leo, if you want to set right here the bullet points that you would see feasible for the next 6 months, one of them could actually be like making the transition also with the new engineer. Could be cool. Alex, the same. So as we said, if you want to add anything more than what is here, do not hesitate. Yeah, I mean, and we could have like private chats on specific topic if you like. So if anyone wants to like take saying that I'd like to discuss with this guy and this guy about this topic, let me know. I can we can definitely open breakout rooms. I can actually directly open breakout rooms, at least 2 of them without any limit of time. If you are willing to, yeah, there we are. Okay. Okay, is there, so here I listed 1, 2, 3, 4, 5, 6 topics, which is actually already a lot, but is there one of the topic, for instance, your topic of development where you know that you'll be active, which is not appearing here? Is there anyone in the audience which cannot find something that he or she will do in the next weeks and months?
So basically, the constraints will also be a subject in the following months.
Mm-hmm.
So I don't know if you consider it in the matrix assembly project or.
I was, but if you think it's better to actually differentiate them, like making them 2 separate topics, that can be.
For me, it's 2 different topics.
Yeah. So do not. Yeah. Let's do it. I'll do it for you here. There we are. And let me know if the title does not please you. You know, if constraint modernization is not. All right. All right. So yeah. Thanks a lot. Are you already like Arnaud, for instance? Are you already chatting with Sidati about what you want to do, or?
No, I'm putting him on the stage directly.
Ah, cool, perfect.
No, but yeah, we previously decided. I mean, I told him that he might be the person in contact later on.
Yeah, definitely. Yeah, and so if you want to take some time to chat, as I said, you can just take one of the 2 breakout rooms. We can create more if needed, and to take the time to discuss. The idea is really to get those, as we said, like usual list of objectives, so that we can in 6 months just get an update of what people actually did, how did it work. I would be so yeah. So Alex, I see you're on the refactoring. Do not hesitate to discuss the question of the constraint. Sorry. And yeah, maybe there is some topics that could be discussed really, like at least with some people. The topic of the constraints, maybe with together, because it's gonna be related to the beam adapter topics.
For me, the only to review the
yeah. C'est map sparse matrix, right? Hop là. Okay, that would be so here. That would be at least with. Okay. Thank you, Anonymous Fox. Yeah, I could have guessed. Cool.
So replace the constraint. What would you see else doing so on this specific topic? So first, is that sufficient for the matrix assembly, Alex? I mean, do you see other stuff that could be done, or François or anyone else would have comment on that? But I think it's already quite dense here. I mean, taking care of
nothing to add. I mean, what I just mentioned is I was curious whether or not this this topic of projective constraint was also like part of, I don't know, ongoing discussions or something that people wanted to tackle in the future. It was just.
I'm sorry. Yeah, I did not catch actually that when I was typing in the meantime before, so I did not catch that. Is that something that you have? I guess it's not really in the plan, right, Alex? Those kind of projective constraint, the way it is actually managed so far would not really change, right?
So this is projective constraints have a small change of API because they kind of contribute to the matrix. So I've done a similar refactoring than in masses or force fields. So I need, but I considered that they work on a single mechanical object. So I need to see if what François mentioned is also working, or if I need to modify the changes that I've done.
Okay, should we add it here on the list?
I don't think it's a priority. It's just as I said, I was curious whether during previous discussion this has been mentioned at some point in.
So the idea of the change or the refactoring that I've done is only how to manage indices and stuff like that. So I don't think it supports more than one mechanical object. But as you said, it's not really a priority, but maybe just a test with I don't know if there is a scene somewhere. That would be great. But because actually I use CI from SOFA, which tests scenes from the Beam adapter plugin, and I did not see any feigning tests. So it does not mean that everything is working, but because one way would be maybe to check if there is a beam adapter example with the projective constraint that you mentioned, and see if I can add a test and see if I can support it or not. I don't know yet, but it doesn't. I mean, I can spend a couple of hours just to check that.
Okay. And is that just regular projective constraints, or again, is that such a projective constraint that would actually affect several mechanical objects that you're referring to?
The regular ones are working.
Yeah, I get
obviously.
Yeah.
But the ones where there is a matrix projection.
I think I'm reviewing like currently like the current projective constraints that are implemented like in SOFA, and I think like most of them, okay, so they don't implement like the system matrix projection. I think mostly because the API was not able to provide efficient method to do it. And most of the case, like if you look like for example at what a project to plane constraint would do, it would impose a sort of boundary condition which only involves one mechanical object. Basically, you say like specific indices of a mechanical object should always be on a specific plane, and you can define, I think, like a plane equation, like for each of the DOF you want to project onto. So you can, and this actually requires to do 3 operations. You need to project the forces of the DOFs, which needs to be on the to rely like on a specific plane equation, like so that the forces do not allow acceleration outside of the plane. So it's a simple rejection matrix product you have to do. And once you have that, you make sure like the acceleration does not allow like to go outside of the plane on the new contribution that you get. You need to do that also for the constraint Jacobian. And you also need to do that on the system matrix to make sure that the derivative also of the forces do not allow to move outside of the plane.
So this is not done yet, right?
Yeah, and that was what I was mentioning. Is just in my up to my knowledge, there is I don't think that there are projective constraints which are well implemented apart from fixed constraint, because fixed constraint it's super easy.
Yeah.
Since it's just zeroing the acceleration in all directions.
All right.
So, sorry, at some point you can shut me down, like if you if you think that I'm talking too much, but it's just like ultimately I believe like if you want
to raise too many problems,
one day in the future you're interested in testing your API with a simple projective constraint, like project 2 plane might be a good place to start.
Yeah. A simple one, but not too simple.
Yeah, exactly. It's just like simple in the sense that it only affects one mechanical object, and the relationships do not depend on some external conditions. So you know, yeah. I think I implemented it like out of curiosity with like a very like the old matrix API. So essentially, I was considering the system's part matrix as a dense matrix, so it was super efficient. But it was working. It was just like I could have a sort of a deformable object which would only slide on a particular plane, so without resorting like to Lagrange multipliers. So it can be helpful to have that.
Okay, so as you noticed, Alex, I added this sentence here, but obviously feel free to edit it or whatever. Leo, the same. I added one bullet point in your list here. It's actually the fact that since you started a bit before, it means that in 6 months you might have ended already your action on SofaGym. So I think it could be really cool that really before you leave, you can like even if it's just like a very small visio call that we do all together along with Christian and so on, but just to make sure that we can gather all the information about where we are with SofaGym. Okay?
Yeah, sure. It's not a problem. It's a good point.
Cool. And hopefully there will be a coverage between I guess there will be a coverage between the period where you work on SofaGym and the period, the time where the guy will be recruited.
Okay, but it's not a problem. I can take time after to discuss on SofaGym.
Okay, cool. I see the anonymous Fox, Alex, which is carry on. So the constraint modernization. So what would be to the point number 3 here, constraint modernization. So refactoring to allow to derive from constraint solver. Yeah, okay. And the idea would be to possibly implement other kind of solvers. Is that correct, Alex? Or
yes. So in the team, one goal would be to estimate the constraint. So the
compliance matrix.
Yeah, the complex matrix in so to estimate it with machine learning.
Yeah.
So we did it with some hacks, but
Do you know which?
better.
Do you know which ones? Well, like which hack is being used to actually input directly things into W, or
Yeah, so we have
brute force?
No, we still use a generic constraint solver, I think. And once so it's still assemble the matrix constraints, etc., and build the W matrix. But once it's done, we replace it by the new one.
Okay.
So it's very inefficient.
Yeah.
But
Okay.
it's working.
Okay. All right. Yeah, in the same. So it's a bit of a troll, but refactoring to allow to derive from constraint solver make me think about constraint solvers and make me think that it would be nice to have something factorized between LCP and generic. It's like a water snake, as we say in French, or a sea snake, which I should say, a sea snake. But yeah, so I don't know. I don't. Is that something that would be of interest for you? I mean, of interest in terms of will that be useful for the team, or is that something that is not? And maybe some other guys, maybe I could like try to take some look at that for factorizing the two codes. Because
so do you?
I'm talking about that.
Do you think about factorization in terms of duplicated code, for example?
Yeah. Sorry.
Yeah, so definitely, if there is some duplicated code, it should be tackled. So yeah, you could add it in the list.
But yeah, the fact is that we have two solvers which are almost doing the same thing, but not exactly. And either we keep two separated codes, but at least we need to make it very clear, even maybe in the names, which are not appropriate, which one does what, because LCP is actually also doing NLCP. So basically it's an NLCP constraint solver, which is especially optimized for contacts, while the other one handles not only contacts, but any kind of constraints. And both, I mean, the name is not super clear. I mean, both names are not super clear. The implementations are super duplicated, I think. So, yeah. Maybe there would be. I don't know if we should actually write really that on the roadmap, or just keep it that in mind somewhere.
Yeah, you're right. It's not really an objective, but
yeah, could be a side bonus that would please everyone to see happening. Is the a bit in the same way on constraint solvers? Is there the need at Defrost for implementing also other other methods to solve the constraint problem? Because here, for the moment, you say refactoring to allow derive from constraint solver being able to compute W with new methods. But is there also the possibility there could be also another like refactoring possible, which would allow to extract the solving part from the constraint solver and make it really like independent, having some independent code for instance, for a Gauss idle, an independent code for another kind of solver if you wanted to have some. So multi-threading is everywhere. Yeah, what do you think at Insimo? Maybe François, do you have other kind of solvers, or do you still only use the Gauss idle?
No, we only have Gauss idle. Looking back, like at the LCP constraint solver, in our opinion, there is at least the working part of the LCP constraint solver is exactly the same as the generic constraint solver. So
yeah, so
there's no. I don't see how one optimizes something that the other does not. So I don't believe like there is really need like to maintain both, but That's my take on the subject. I mean, I remember like looking at it like a long time ago, and I don't think I saw anything like particularly different like between the two. Anyways, and
even in terms of performances, even in terms of performances, if you only have contact.
I don't believe so. I haven't checked like the NLCP like does like how they are actually solved, but for me like it calls constraint correction API methods, and most of the time spent is actually building the compliance. So it's I don't see why it would be, or at least there is nothing clearly better done when it comes to assembling like the system. It would be, I would have a different take on the topic. It would be like a sort of an unassembled matrix 3 version of the Gauss idle that was going to be used in that solver, but that's not the case. So, no, I believe that they are building exactly the same system, and the only thing I see is there is some options like for multi-grid solving, which I suspect could be actually very well replaced by what is Alexandre is doing with matrices, because kind of thing like a multi-grid method are actually condensation of fine matrices into coarser ones. So I don't see why this logic would be implemented by the constraint solver.
Yeah,
that's my point on that. Maybe it needs like to be checked by someone else, but from a distance and from what I remember, I don't think that there is a how to say that, like a reason like to maintain the two, like even in terms of functionality.
Okay. I think
yeah, in terms of sorry, go ahead, Hugo.
No, I was just gonna say that's something I'm gonna ask. I'm gonna ask also Christian if he think about any difference and whatever. But otherwise, yeah. But if there is definitely nothing that would make one better than the other, then we would definitely just drop one out of the two, and most probably the LCP, because generic handles really any kind of not only unilateral ones but also bilateral constraints. So
I don't think that it's the LCP will also handle any of this, because it's this part like you're mentioning, like actually like the constraint laws that are being implemented like for actually handled by other it's not component but other objects which abstract like the local solving of a constraints, which are named constraint resolutions. And it's a terrible name, by the way, because it doesn't mean it should be named local constraint solver or constraint law, because constraint resolution, it doesn't mean what it's supposed to mean in English, because resolution is like a definition for a screen. So it's yeah. Anyways, that's another topic. But essentially this object is responsible of the local solving of a particular constraint law. So if it's bilateral, it's just you invert just the linear relationship. If it's unilateral, it's linear relationship plus projection. And if it's friction, it's just estimating the normal force and tangential forces and projection onto a cone. So that's so this is what these guys are doing.
Okay, but what I meant is that by using the very same scene involving, for instance, contact and bilateral interaction constraints, you won't have the same behavior using the LCP and general constraint solver, I think.
Okay, so that's interesting, but that as far as I know, it shouldn't.
Okay.
Shouldn't. Unless there is some, yeah, it shouldn't, in my opinion.
Okay.
Some kind of stuff where the LCP assumes that you only have rigid objects, and in which case it will sort of optimize the Gauss idle by just looking at the block diagonal. So that could also happen. Because back in the days, or you had like components called like I don't think like not a lot of people are using them anymore, like for I would say like accurate simulations, but some guys called uncoupled constraint correction. And it's an implementation of a constraint correction where essentially you assume that the system matrix is only a mass and it's only diagonal.
Yeah.
Basically, you directly feed like the
diagonal of W. Okay.
Anyways, and you had questions about how we do multi-threading, like in this stuff.
I see two bullet points that have been added by Alex.
Essentially, this is what we're doing. That's the two stuff that we're doing. Parallel matrix assembly for the compliance, and or maybe that's what you meant by operations, is the fact that we distribute the matrix assembly and we scatter it into as many sub-blocks as we can possibly do, and we have a parallel version of the Gauss idle for dense dense system.
So right now, I think when you do a minus one times what h, I think h on both sides. So ht a minus one h.
Yeah.
So this is done in the linear solver. Actually, and this could be parallelized. So because so each column is independent. So parallelized is so this is the only thing that we have done. But we have not divided the matrix itself in block.
Yes. Yeah, that's sweet. Essentially, like we parallelize slightly more than just attacking column by column, and because you gain a little bit more than by going a little bit further.
Okay.
And I don't know if you do that as well, but I suspect you do. In the context of collective factorization, like it's better to actually compute like L-1 if you have the L matrix of the collective factorization times H, and as opposed to doing like M-1 H transpose and then pre-multiply by H on the left. I don't know if I'm clear when I say that.
No.
Essentially, you just have to do like the forward substitution with L instead of applying the whole inverse. Maybe I will have like I can have access to a document. I will write it.
Great, it would be great. Yeah, because I've seen that this function is virtual actually, and it is overridden in the FTL server. So I think so. I don't know exactly the details, but I can guess that they are a bit different and optimized than the generic case. So maybe this is what you are talking about.
So a point, and there is already someone who will reply. If anyone on the especially on the Unity side, is that you meant? On the on the point the number 4, so far rendering using Unreal Engine, Unity 3D. If there is needs or needs from people from the community from specific features, do not hesitate as well to make that kind of feedback to Eric or to any employee at in FinTech 3D. But yeah, definitely do not hesitate to add anything on this very small, on these very like those four bullet points. I added a very small love letter at the end, especially I think that it would gives a lot of advertisement to SOFA.
I was wondering if, like, in what you currently do, I'd say the Unity app runs as an executable, or it can run in a browser. And if it runs in a browser with SOFA, can you run it, I would say, in the cloud? Basically, I'm trying to find a solution where you can run what you've done in the cloud. I repeat the question so you can think about it. The question is, it'd be potentially very interesting for some people to be able to run Unity plus SOFA in the cloud rather than running it as an app directly on a computer. And I know Unity allows this, but I don't know if your plugin.
Yeah, what we could do. I can, I guess. I'm not speaking about your plugin itself, just Unity itself, because I tried. You can have, I guess, a product generated by the Unity, SOFA Unity thing will be an executable, and you can normally, I would say, stream to a port like 5,000 something. I mean, when you deploy, it's written somewhere you want to stream. At the time when I tried, it was like 1 or 2 years ago. It was a beta version. I mean, everything. But now I guess it's better now. So I guess you can stream. But the thing is only one. At that time, it was only one way, just to display. There was no like backward interaction, like touchpad or something. That this kind of stuff, I don't know. Maybe you can do now feedbacks, interaction, I would say, but I don't know.
I think you answered. Yeah. Yeah, the idea would be to have. So you could deploy SOFA inside Unity in one server, and then you can use any Unity assets to do some browsing, webcasting, etc. And after, if you want to deploy on any platform, you could do it with Unity. You just need to make sure that our SOFA library is following the same, is compatible with the platform you want to deploy on.
It's in your task, on which platform you want to be able to execute. I'm thinking Windows, I'm thinking Linux, I'm thinking Android, I'm thinking iOS. So where do we want to go? For free. It's up to you. I mean, if you want to make money with that or not. But, I mean, maybe you know more the market.
For first version of the Did you hear? Yes. Yeah, it's okay. Yeah. Yeah, for first, for this roadmap, I think after we will see, depending on if millions of people want to use SOFA on Android or not. exactly, yes. You need to understand, yeah, you need to think if there's a good reason to do that, because if you export on a smartphone but there is no good processor, there's no yeah. So far normally has been made to do some big simulation. So
one could
well, it's an open.
Okay. Okay. Could you hear like Alex and Son? Could you hear well what was said, or it was a bit too far?
Nothing.
Okay.
Yeah.
Was the silence comfortable? Okay. Is that turned really on,
Yeah.
or?
Can you hear me?
Yeah.
Alex?
Yeah.
Alex. Alex. Alex, can you hear me?
Mm-hmm.
Ah, okay. Could you hear the discussion just before or not at all?
Not at all.
Ah, okay. So I will do a very brief. Yeah, I'm sleeping. Yeah. So just to we just said that we are gonna create a public version of software integration inside Unity and Unreal Engine, but only in read-only mode. And for the moment, we will only deploy it on the main platform like Mac, Windows, and Linux. We will see after, depending on what people want to do, if we consider deploying on other platform. And that's all, I think.
Okay. Shall we just take like a 15 minutes break just for coffee? I would like just to take a bit of. Is that okay? Just take a bit of it and. Tac. Here I'm just sharing the slides. Okay, so let's carry on the discussion, and we'll complete basically the roadmap right afterwards. There will be especially the discussion about the. So I think DeepPhysX, it's for you for your Robin is pretty clear, since that's basically completing the tasks that were not completed for this roadmap, and you're going to move from topic. And then there will be the topic of Caribou, and maybe we could just pursue a bit the discussion that François started earlier, also on like mechanical model on beams, possibly related to Caribou and stuff like that. With I know Arnaud is here. He contacted also Sidati, so just to get this last topic being discussed, and then I think we should more or less we would have covered basically all the topics, I think, except the beam one that will be on Friday. So if it's fine for you guys, so see you in like 14 minutes if it's okay. Okay, take a coffee wherever you are, and see you in 14 minutes.
Devant le micro pour que very complicated. So this was more to validate the physics.
All right. I hope you all got the time to actually grab your coffee. Yeah, cool. Thanks for sharing the presentation, both Eric and Robin. I got all the slides. Perfect. If I go back on the slides, so basically we're gonna have we're gonna discuss the very last point, and then we will like review and finalize the roadmap. There will be I'll voila, so that you can. I'm just preparing it. Where is it? Here. Oh, it should have. Yeah, I did not updated my slide here. I need to leave and get back in there. Just before we address the last point for tomorrow and Friday. Friday is the day a bit about beam models and so on. So nice to have you, Camille. If you can join us. Anyone else interested can obviously let us know. We would share also the Visio access. But for tomorrow, it's going to be first for us on site. It's not going to be here. It's going to be at Insimo's building. I think for the morning, what's going to be the way we're going to do things is that we're going to make more like a coding sprint morning. And the big discussion is like at 1:30 after lunch. About like all the possible, how to actually envisage the future of SOFA. We have already discussed that a bit yesterday with actually a drink or two or more to actually think about how things could evolve around SOFA. There is a lot of different point of views. I think it could be nice to really discuss that. I even think that the 1 hour and 30 minutes track is maybe a bit too short. We'll see if we exceed or not. But yeah, that's going to be I think the main part for tomorrow. There will be a discussion about collisions that we wanted to address. And GPU development, it will simply depend on who is actually active on GPU, and it will be very linked to the point of SOFA 2.0. If what kind of updates could be brought to SOFA or to some kind of new version of SOFA. GPU can be one of them, but for that we need to have like GPU contributors that we don't really have in open source so far. So if we don't, I mean, that's a topic that would not be very relevant to address if no one is active on the topic. Okay, that was just for tomorrow, just a short update for tomorrow. Let's get back to you can't see my whole screen. I'll share the right window there. Okay. There you are. Sorry, it's not this one. I start being too tired. There, okay. There you are. Again, I can recopy paste into the chat the link towards the document so that anyone can have that under the eye, or edit it or whatever. And the last point we wanted actually to look at was there. The point about, I would say, basically biomechanics, whatever you apply mechanics to, but related to Caribou, related to the coupling between SOFA and Phoenix that was presented by Arnaud earlier. That's definitely, from what you presented, Arnaud, a topic that you'd like to push in the next weeks and months anyway. So especially the merge of the feature branch that you have into the main one, the test and so on. Basically everything which is written down here. So that's also super cool to see that there is this internship starting at University of Luxembourg on isogeometric analysis. More generally, so yeah, Stéphane, you wanted to write. So it's going to be also the next topic from Robin, like differentiable simulation that could be linked to Caribou. But basically, what would be the future of this code? So far, we really would like to have like engineers, one engineer dedicated on Caribou. It's something that we're gonna put. That could actually be. I'm gonna add that on the list. Request dedicated engineer on Caribou, so that we can have actually someone who is like knowledgeable and who actually manage the plugin. I would say almost 100% of his time or her time, whatever. If it's not exactly 100%, but close to, basically what it would be his or her main work. Do you want to like add something, or would be curious, Eric? Can I? So do not forget to eat the mic. Huh?
Yum, yum. Yes, I think that if I'm totally honest, we're missing some features in Caribou to completely match what currently exists in SOFA outside of the plugin. And I would say the two main things are that basically there is currently no support for surface models, okay, like membranes and shells. And the second, and this would not be so difficult to implement. Okay, so this is something that doesn't exist, but brings pretty much no change. The thing that does not exist also is the support for mechanical objects that have more than 3 degrees of freedom, such as the beams, but also there are some types of shell elements that require 6 degrees of freedom per node. And that's a bit more of a challenge currently to bring that into Caribou because it was not designed. So it's not just a matter of template, but it's also at other levels. If we solve this, then we can bring everything we have in SOFA, classical, I would say, force fields into Caribou. And that would be personally on the top of my priority list, because if we can do this, then re-implementing existing force fields would not be a lot of work. But at this level of those last 2 points, there is quite some brainstorming to be made. And then if we have this, I think that we could progressively get rid of the other force fields in SOFA. But right now, that's why, we have something very interesting in Caribou because it's easy to bring, it's more modular. You can bring, with what we've done with Sonics, additional complex material laws. But we cannot pretend today that this could completely replace what exists in SOFA. But it's feasible, but we need some help on that. So I don't know when we could do this. It's really more a brainstorming session that we would need on that than anything else.
And yeah, I wanted to ask something.
The integration with Python works well. I think people get more easily involved in the code because it matches better what you can read in classical FEM book. So there's less of a jump. And then we've done lots of validation indirectly when we did the work by fusing a bit SOFA and Phoenix, because we compare several solutions and they all pretty much agreed. So we're in good shape.
On this topic of validation, Arnaud, it could be nice also to have directly, I think, in the Caribou plugin, like the paper, like a PDF. We don't care. I mean, it's not like a huge mesh or whatever. So, but to have the documents basically which are assessing the accuracy, the efficiency. I don't know about the efficiency. That was my question of FEM, like basically from mechanical FEM from Caribou compared to the one of SOFA. Is that completely equivalent or?
I think it is, yeah. But I don't know if we've done an extensive benchmark.
Okay.
That'd be a thing to do.
Yeah.
But as far as I remember, on some very specific tests that I think CDATI performed at some point, we were seeing no difference. Because the solver is outside of Caribou, so in the end, it's more how we assemble the matrix, and I don't see any possible slowdown in that.
the topic of the topology as well. Don't you think that the topic of topology is also something? I mean,
yeah.
could be actually a reason to keep only few of the current the FM codes which are currently in SOFA, to keep them maybe for topological change purposes, so that we have like very completely embedded codes that can very well support the topological changes, and having like some more, like we have the mesh topology for static meshes, we would have then the Caribou plugin for some kind of static FEM. I mean, yeah, it could be a frustration, and up to some point we could work on that, but it's just to remember that the topologies are like not equivalent, even if there is connections, I think, that were made, right?
Yeah, we had discussions some time ago with Eric, so I don't remember the details on that. At some point, yeah, everything's possible. We all know that, but how much work would be needed, I don't know. But it sort of goes, actually, this question on the topology also goes with what would be needed for having surface models in Caribou. So Jean-Nicolas made some simple choices for representing the topology. And I think if we find a solution, maybe it could work both for having dynamic topologies as well as beams and surfaces.
But yeah, and don't you think that because you're saying that for instance on brainstorming, or even because even developments, we could on one topic, which could be, for instance, the support of surface FEM models, that could be like shareable and say, but for sure is that the 4 bullet points to address them all, is especially in the next 6 months, looks like not possible. I think that's what, unfortunately, but it's also the way it works, that people like to follow like one lead. That's the case on reinforcement learning for soft robotics with SOFA-GYM. That's the case. I hope it will be the case with DeepPhysX, the DeepPhysX platform for learning in biomechanics. But so having still one guy or whoever, but active on the topic, and then getting other feedback from Arnaud, I'm sure if we get someone active, Jean-Nicolas will get way closer to the topic again, because it's going to get excited for pretty sure. So
maybe I don't know. It's I would say an optimistic view, but if we had maybe even a summer intern working in this, it could work. But yes. There are lots of pieces around that, taken independently are not a big issue. But if we want to really go at this and make sure that we make the right design choices, first, to me, the key is that we have input from multiple people, even if they are not necessarily involved in the development, but making sure that we address this correctly. But I don't know if that list of 4 points is too much for the next 6 months.
I mean, on my point of view, as long as there is no one really active, any of those points, even alone, would be already too much. It does not prevent from discussing. Definitely for seeing, especially really from 3D to surface FEM model. I think this is I don't know. I don't know enough Caribou for that, but it appears to me it should be really realistic to address that. The second one, I guess it's way more complicated. CMake, it's just another topic. Yeah.
And I'm thinking about Remy, who is now going to be using Caribou. I don't know if
Remy, are you around here? Yeah. Is that you, Arnaud, that wrote that sentence about like getting in contact with Remy, or?
Oh yeah, it's me who wrote it down.
Okay,
wrote it down.
but for sure you will be okay with that. I mean, I'm sure you would be like agreeing with the fact that they are really like interested and like they need to see this code evolve, to the plugin to evolve. They need exactly the kind of things that you were mentioning before, which is like accessing stress, strains, tensors, and displacement fields. Basically, not really ghost points, but just the nodes of the mesh. So
I'd be pretty sure that in the application they are looking at having a surface mesh is going to be needed.
Yeah.
So maybe this is one place we could start from. And again, it's really difficult to evaluate the level of complexity that's needed to do this, because maybe it's just a matter of having the good idea. If we have the good idea, on the first meeting, maybe it could be super quick. I'm a bit more worried about the more than 3 DOF part, because it goes deeper into many choices that Jean-Nicolas made, where basically, yeah, it's certainly not templated and not designed to work with more than 3 degrees of freedom. The thing is, even for shells, we could go a long way using only 3 degrees of freedom per node, because we could have the classical, P2 elements where you have nodes in the middle of the edges, and they could stay 3 degrees of freedom per node. It's only for the beam, because even the closest thing we have to our current beam model, where you could also put some additional nodes on the edge, they would allow to have everything we have on the beam force field now, except the torsion. Yeah. And to get the torsion, the torque, whatever it's called, you need an additional frame. And I don't see, because we looked into it quite a lot, and we could not find a way around having 6 degrees of freedom. This is the only thing we have in so far, to be honest, in terms of force field, where you need 6 degrees of freedom for a deformable object. Everything else you could do with 3.
Mm.
So it's...
Christian, I saw you were posting. Do you have any opinion on that as well? Sorry.
Yeah. Hello. Je mets ma vidéo. Hop. Je sais même pas si ça donne la vidéo. Attends, du coup, je me vois pas. All right. No, I was not sure about your point, Stefan, because if you have, even if you have a quadratic element with shells, but if your shells are flat, there is a unconstrained rotation along the edges, right? Or you need to, I see some elements that takes not only the element itself, but the neighbors, but that means that it's other type of elements.
Yeah, we looked at many of the, on I forgot which software, it's ANSYS or LS-DYNA. They have the list of all the elements they use in some very extensive documentation. And when you look at shell elements, pretty much everything uses variations of the same idea, where you have many 3 degrees of freedom nodes on the surface of the element. Okay, and I have not seen in the documentation of these commercial packages examples where you use, like we did some time ago, 6 degrees of freedom per node. And I'm not saying we should throw away the 6 DOF per node thing.
5. I think there are some usual way with 5 degrees of freedom. You remove the rotation along the normal. But
yeah,
anyway.
there's also that. But what's for sure is whatever we do for the shells will not work for the beams. And then, since lots of us use the beams, we have to find a solution in Caribou to bring nodes with 6 degrees of freedom. I think that's the bottom line of this. Is I have not seen a way to get around that.
The other possible solution is that we are using more mappings. And in fact, in Caribou, you are always considering particles like we use in continuum mechanics. And basically, if you want to compute a beam, you map your beam, so your 6 Dove degrees of freedom, and you move the particle of like, I don't know, a meshed beam with the hexagon element. So at the end, you compute something that is in a reduced space, but the force are computed at the level of 3D elements. You see what I mean?
I think I see, but not completely. But this is exactly the kind of discussion that I would love to have in more details when CDATI also is a bit more available. Because yes, maybe getting where we want to go, meaning bringing the key force fields we use in SOFA into Caribou is not as complicated as we might think. And yeah, those ideas are very good. And
for instance,
yeah.
just one example that we with beam elements. So the beam elements, the hypothesis is that there is no deformation along the section. Okay. So if there is no deformation along the section, and you just elongate the beam, it means that you have an augmentation of the volume by itself. Okay, so in practice, it means that it's really complex. So it's not even possible to constrain, for instance, to have iso volume material with a beam element itself.
Yeah, because they are assumed to have no. Yeah, I exactly see your point. Yeah, yeah.
So for me, I'm not sure. So I think beam is really a simplification of. And maybe it's not so important. I don't know. I don't know how important it is to look at it. I know that with
just a question. If I relate what you just said to what you said before, in a way, what you're saying is we should forget about this. I mean, we should forget. But one option would be to work directly with a true three-dimensional version of a beam, right? So that, for instance, when you compress or extend it, you can compute volume changes and things like that. And so, then everything would be 3 Doves.
More precisely. Yeah. And the point is that for me, if you are using so in Caribou, I guess that the constitutive law equations are very precise, much more precise than what we are using in a beam adapter, for instance. But it makes sense if really the kinematic of the deformation allows the complexity of deformation. Otherwise, it's just you are the assumption of the beam are sometimes incompatible with the assumption of the constitutive law.
Yes, I would see some. Yes, if at some point, especially in Caribou, you want to put some advanced material law on a 1D strut that's called the beam, at some point it would make no sense. Yes, totally.
So that, no, yeah. But I don't bring any. Maybe one question is on your project. Would you have some support to continue to work on Caribou, or like you really lack some support?
Well, the only place where we could get support outside of INRIA is that there's this big project with Dassault system that should happen, and that's on digital twins of the liver in particular. So where basically, yes, having a more advanced model of the liver implemented in Caribou would make a lot of sense. And this is a place where we could get engineering resources, and not just engineers, but also PhDs. So this is the only project which is not granted yet, where we could have someone. So if we're lucky, something will happen. But I'd be, again, just to restate this, I'd be super interested in having a, couple of hours of discussion on this topic with you and some other people like Arnaud and Sidati. We also have a student from Germany now who is spending a few weeks with us. She's working on stent modeling, and she also has her own implementation of beams and beam type structures. So it'd be interesting to discuss that maybe even with her. Because if we come up with some good ideas, but for the next few months we don't have anyone to implement them, that'd be okay, because at least we have a plan, and as soon as we have a resource, we could go for it.
And I was wondering.
That was exactly my question about. I think we should really. So now that we have the plan, so so that was my question. So at NC, so if there is an opportunity of financing, we should keep that in mind. And
yeah,
we can still, for instance, I would say work on the plane which is supposed to bring Arnaud to Australia, and just make the plane avoid to take off and keep Arnaud with us. But yeah, that's and because it means we will need to have a profile which is both mechanical and computer science, enough computer science so that it can get into Caribou. And I just wrote something which basically, and it's a question for both of you. What would be is there really a need to have beams in Caribou? Whether because since we have also COSRA on the other hand, if we have a way to just add, I would say, also constitutive laws as we have like in Caribou, add the new constitutive laws in COSRA. I just don't know. Again, that's two kind of first an approach, and another one which is a model, a theory, COSRA, which I don't master at all. So I'm just wondering why we would need actually beams within because what I see from Caribou,
it was actually my point with. So let me give a new example just to illustrate, because we've been working a little bit on trying to implement plastic effect in COSRA with Camille. And the problem we have is that in fact the plasticity appears not. So if you are looking at a section of a beam, when you deform it, the plasticity is not the same for all the points on one section. It's basically there is more compressibility and extension at the points that are far from the neutral axis. And so it means that to compute this, we need to introduce some mapped point, on the section. So we need to create ghost points on the section and have a specific constitutive law for all these points to get something that gives basically the force on the section. So it's a good example of showing that with beam or with the COSRA, if you assume that all your section is elastic, you can do some, basically you can do a mean of behavior for all the particles on your section. So, but it's only true for linear elasticity. As soon as you will introduce non-linear terms, you will have to look more carefully at the behavior of points on your sections. Somehow you will have to create a new discretization of your points, and so that's why I said that maybe it's instead of trying to introduce complex, 3D, so I don't know, 6D model into Caribou, maybe we should just create some mapping that gives you basically the relationship between motion of degrees of freedom of the beam to the points that we are moving.
In plane, you mean to the basically to the integration plane, the integration point in planes.
Yeah, exactly.
I think that could be a good idea, yeah. And to me, the main objective is not to bring everything we have in so far into Caribou. It's just to reach a point where it's a bit like what we said between the LCP and the generic constraint solvers. Having two pieces of code that pretty much do the same thing means that someone will use one, someone will use the other, and then improvements and bug corrections, they get made randomly. If we end up having everything except maybe for the beams and even maybe in the long term more than that into Caribou, then that would become the main source of FEM models in SOFA. And naturally, as soon as we're at this stage, we'll get more support, feedback, testing, and everything else. But now it's not possible because we don't have everything covered. That'd be the goal.
And just one question also for maybe for Hugo. I don't know where. So, what is the state of doing classes with more advanced classes? Yeah, the solve.
Yeah.
Teaching, and because I think what is nice with Caribou is maybe that we are closer to mechanics.
Yeah. No, it's. I mean, on this, there is nothing changed on what I would say compared to even last technical committee. It's. I'm convinced that Caribou, if it was like, I think, firstly, better integrated within SOFA. That's the third point that I added here. So basically, on the CMake side, so that it can really get easily fetched when you're from SOFA, within SOFA, being used as an internal or external plugin, which is not the case yet. And secondly, if we would have like really people who would have a good understanding of it, available to also help others to level up. And I think that's the two, for the moment, the two blocking points where CDATI is a bit like the goulot d'étranglement for those questions for the moment. There is also Arnaud who used it, but who naturally is also saying sometimes, yeah, that's a question that we should ask to CDATI. Yeah, that's why I think we need this like central guide that would actually work and be focused on Caribou for some time, that we could ask like to help others to level up. I would like definitely. I mean, I would definitely like to get into the code and so on. But regarding the time of development that I have, I can then sacrifice other tasks. But it's I mean. C'est vraiment without taking just an idea. I could dedicate time on that, but it's something that even if I do, or even if anyone actually, or several people do, we might face still the problem that we would need to still CDATI for a month, basically, to really extract everything that he knows, taking time from Jean-Nicolas as well, that I'm sure he would be ready to. Like every Friday, we could actually take, as we were thinking about doing, Fred, having some discussion with Jean-Nico, informal, but also maybe sometimes on Caribou, could be doable. And you're perfectly right. I'm sure if we get this point, only of integration of SOFA and a bit of doc, and therefore training that comes with it, that's a whole community that we can address with it, a whole community.
But maybe let's just start with finding when Jean-Nicolas would be available for like a couple of hours. because I think there are some aspects of what has been done in Caribou that are only justified by the fact he had a PhD to do and a limited time, and others that were, okay, you know, I'm not going to do that right now because it leads to some additional complexity. Having, you know, his feedback on what he's done and what is not done and why. At the same time, we can bring Christian, Alex, and I know whoever wants to join, plus Sidati and Arnaud, of course.
Remy will basically have to level up on that as well. So
Remy could come also, you know, a day every week here to the city and work alongside Sidati, or just have someone next to him.
I mean,
I put 2 links in the chat. It's interesting. I think it's recently there was a paper in the soft robotics community where basically they have done some soft robots are mostly made of silicon, but there are very often the same silicon used. And what they did is a database of hyperelastic parameters of often used material in soft robotics. So what I think if we are able to, you know, to show that we can from this database directly implement this into SOFA. So I'm sure that's it's a really. So I'm sure at least the soft robot community will
jump on it.
So I think we should push, you know, on this for finding some resources. At least I can try to push.
Yeah, and also I remember that Arnaud in his PhD was showing some other tests of you know, cylindrical silicon object, you know, under just deformed under gravity, but that's well characterized as well. So yes, we have a few things on which we could validate or test Caribou. I'm just going to jump on one related topic. I know it's not directly part of Caribou, but again, so this lady who is spending some time with us, she does all of the rendering of her computation in ParaView, okay? And it's beautiful because you have all of the nice shading effects, colors, you know, for the stresses and everything else. And we're still missing this in SOFA, I think, at least at a level where it's directly in the GUI and not in an external thing that, you know, because for ParaView you have to save your data and then you just play back your simulation. And the reason I'm saying this is if we really want to bring the mechanical engineering community or computational mechanics community to what we do with Caribou, this visualization part is also important. It doesn't have to be fancy. I think it's probably a lot simpler in a way that some of the things we do. But I know that directly in SOFA, it's not so easy to do right now.
Hi, Vlad. Are you going or?
Yep.
Thank you for. Yeah. Thank you for coming. Thank you for taking part at the both symposium and the STC. And yeah, have a safe trip back. Yeah, bye bye. But I think it's something that should be like quite pretty straightforward, right? Just to or for me.
Yeah, I mean, it's just a side note because again, when I see what they do in this group, you know, they develop very similar things to what we do, and they don't bother having their own visualization software. They do everything using ParaView. But for SOFA, it'd be nice to have things, you know, maybe more internal, and you know, we have our draw method in the force field, but I think they have their own limitations, and maybe something not necessarily super fancy, but just a bit closer to what this community is used to see would be also a very simple but efficient way to attract them.
I think this is also on the road of Remy. I don't know if he's maybe he's not like where we use we and Arnaud, yes, we could export things as VTK indeed, but so I think the idea that you have, Stefano, I mean, the point is more would have to get that a bit more integrated. But similarly to what we said before regarding having like stress-trained tensors available, that was exactly the point of the guys from the company of Remy, where they actually intend to visualize that and to have that kind of live visualization, maybe for more, I don't know, to have a more advanced visualization, but at least they need this information and to visualize it as well. So they might come up first with a Python solution, for instance, and on my opinion, for that, the most important aspect is to have access to the data and to have maybe one example of visualization. And I think first could be just in Python, using Vedo or whatever other tool to visualize it, but it would mean that in one script you can do all that pipeline. Okay. So we could first we could still like keep a bit of time for discussing those I would say mechanical topics. There is a topic that I did not like bring up is the one you took actually, Christian, about like advanced trainings. I actually did not really have the time to. I mean, the second half of the year, the second semester of the year, because of the SOFA week, is always a bit like a bit fuzzy for me, especially this year. But maybe we could like early 2023 really start having like build up materials that for both the mechanical aspects, the FEM aspects, the collision aspects would really help to have like materials first to train, maybe using those materials to make documentation, improve the documentation. And it would maybe then later on help people to implement new ones, because if they do not even understand the pipeline of collision or constraint resolution, of course there will be no contribution. So that's something that we can definitely keep in mind, but something we need to enforce ourselves to take time for, because it's like not something we are thinking about on an everyday basis. We don't like wake up on the morning Monday morning saying, oh, this week we're gonna make slides for FE simulation and so on. But yeah, that's something maybe on maybe my own like to-do list for the next 6 months. I should actually keep that in mind. I don't know what you think, Christian.
So we had a discussion. I don't remember if I told you that, but even for everyone to know, is we had the discussion about that during the seminar of the team, and in fact we were it was before the summer school that we organized, and I asked people what type of class they would be able to to give. And in fact, now during the summer school, we created some contents. For instance, I gave a class on basic how to link continuum mechanics and in particular hyperelasticity with FEM. And so of course it's an overview, and there is no on this part there is no how we implement that in SOFA. And we had another class that we work with Eulalie on the constraint pipeline. So it was again it was more the the theory, and then we had the practice, but the practice were really on some tutorials that we have in the team, and particularly the tripod tutorial. But anyway, this content exists now. We can expand it. We can start. It could be the start, the basis for that. For me, is that the way it will work is that if people propose some content, and then you have a catalog, and then we can propose this catalog, and if we'll see if there are some interesting people.
Mm-hmm.
But it could be a couple of it's a class plus a person able to that has prepared some content and able to do the class.
Mm-hmm.
And of course, if there is a demand, we can probably develop this content.
Yeah. And
I suppose why not having a complete so the way I see it is that we could already given what we have, you could already diffuse the information that this class could exist if some people are interested. And when, for instance, we have at least, I don't know, 3 or 4 people interested, then we create the class and we go.
Yep. Yeah, I think the best way to do that would be, when people are actually contacting us for getting training, and on the training page to get a very simple but also pretty clear form that would really highlight that not only you have an introduction course, but you'd have more advanced ones, and clearly listing them where people could actually cross what they are interested in, whether it's from INRIA, because there could be also like newcomers that say, I need a training, I need to level up on this or this topic. So that would force us, basically, as you said, to create the materials if we don't have them.
You could, in fact, you can create a kind of marketplace for class. So people that have a class that can propose, they can propose their class, and then you have people that know.
The first idea is being that it could be also the case on topological changes, by the way. Really? And the idea behind that being that our purpose is to have people who are really leveling up on complex topics. That's I think really super important for us.
And in terms of I think we will have more people also interested, motivated to give class if they are paid.
Yeah,
this is clear now or not?
Yeah. This can be done. Yes. Yeah.
Okay.
Yeah.
And how does it work concretely? So
it
can be anyone. It has to be someone paid by INRIA.
That's this I don't know. I need to check, but this I need to check. But for sure, with the INRIA Academy program now, it's something that is actually feasible.
Okay.
I'll write that down. I'll get back with the info. Okay. So far for me, I don't know, but for Caribou, as long as we don't have like someone really clear, you see what I'm highlighting. As long as we don't have like someone really active on the topic, it's hard to. We can make meetings and make discussions, as we said with Jean-Nico and Sidati and others, but making that appear on the roadmap appears to me a bit like could be misleading to the community because it's not something that will, I think, evolve. But there will be definitely the updates from Arnaud along with Sidati on Sonics, continuous integration, CD tests, and so on. Everything that has already been added could be already discussed also with Remy later on. If I get back here and share back the presentation there. Yeah, here. So basically, if we had to like review everything that we said so far since this morning and this afternoon, that's basically this that is actually coming up. So there is indeed one thing missing here in the slide that I actually should add here. If I can, it's got some internet issues. It's called Cosra plugin. So it would be a topic about beams, basically Cosra plugin and beam adapter. So the cost for, so I did not put that. I did not before. I think I put that on the slide just because actually for beam adapter we're gonna have the discussion on Friday morning with Camille, with LN Robotics, with Mimesis and so on. So we're gonna have like a beam adapter oriented discussion on Friday morning from 9 to 12. And for Cosra, we needed the feedback from UNES. So for the moment, I did not make like that in the slide, but this will appear at the end of.
I can give some feedbacks if you want.
Yeah.
On Cosra. Yeah, sorry for this morning. I was not able to.
No problem.
So basically, so basically the Cosra plugin, the originality of this plugin is that the model is computed in what we call in the strain space. So concretely today, you on the Cosra beams, you consider only flexion. So yeah, torsion and flexion. Ça y est, le nom m'échappe. Bending. Sorry, thank you.
Bending, yeah.
Bending and torsion, and so you have basically for bending you have basically an angle divided by a length, and it's the same for torsion. You consider kind of angle divided by the length. That's the unknown for each beam basically. And then the big component in Cosra is the mapping between this space where you do the computation of the model and the frame that describes basically the 3D modeling of the Cosra beam. So it's inverted compared to beam adapter or to the FEM beam, because here you are working in a local coordinate. And so we did a improvement in this mapping, in particular because really this is a central component in the Cosra plugin. In particular, now it's possible to online change the size of the beam, the distribution of the frame on the output, etc. So we did that to have the same functionalities as beam adapter and to be able to change the length of the beam online. So yeah, now the plugin is working quite well. It has been also extended. Again, so the question this morning was how you can do a model order reduction out of that. It's just the good thing of using this local coordinates is that it creates a space that is completely linear. It's a vectorial space. Whereas when you are using degrees of freedom with frames, the rotation is not a vector space. So as here the degrees of freedom are vector space, you can easily reduce the number of unknown by interpolating basically the strain. So you can use linear interpolation, cubic, quadratic, I don't know. And we implemented that with very simple mapping that just map basically these polynomial functions to this angular rate space. It's called an angular rate, basically. It's how we call that in the Cosmos. What is again central in the plugin and what is more difficult is the mapping, because this mapping being non-linear, we are today able to compute it's all the usual function of a mapping, so apply G, apply dt, etc. But here the derivative of the mapping would be very important, and today it's not something that we did. We still need to improve because if there is a constant force apply on one frame placed on the COSRA, you could have a stiffness created by this force due to the non-linearity of the mapping, and that's the typical stiffness that we want to compute. And that's pretty it. For the COSRA plugin, I don't think there is much more to say, but feel free to use it to give us some feedback. Oh, also, I don't know if Younes already showed that at the last STC, but he also implemented 3 tests. That's good because these are tests that exist. So where we know the exact solution, and you can compare the result of the COSRA plugin compared to the exact solution.
Yeah, I think was that the loop made, the different kind of geometry that is done.
Yeah, there is the loop, there is the so torsion, flexion, and there is one thing is that it's a perpendicular. So you attach a beam from one side, and you have at the other side you put a force, but that follows. It's called the following force. It's a perpendicular force that follows the deformation, and you have many strange static position. The more force you are putting, when you are increasing the force, you are it creates a complex shape, but there are some existing results. So we were able to compare that with these results.
Okay. But yeah, I do remember. I mean, maybe it was he added some additional, but I can at least remember of 2 of those tests that he showed us. So I would anyway contact Younes so that he confirms or adds some bullet points tasks for concerning the COSRA plugin. All right. We are now only French people, actually, except maybe I think there is Wang Yu, I think, who is around here. I think, yeah, that's otherwise we are mostly French guys. Thank you, Wang Yu, for representing the global international community at yourself alone. So yeah, I think we're gonna basically stop here with the 8 different bullet points for 8 different topics for the roadmap. It appears to be a lot, but in fact, the 2 refactoring of matrix assembly and constraint modernization are actually pretty linked, or at least just by the developer in charge of it, which is Alex for both. Eric, same, which is both on Unreal Engine and Unity 3D, basically having way to render SOFA simulation in engines and external engines, and entering plugin. And then there is Leo on SOFA Gym, Robin on DeepPhysX, and Arnaud and Sidati on Caribou. And I'll get back to the beam topic with Younes and further to Friday's discussion. Is there anything else? Anything missing here? Otherwise, I would definitely be happy to add it or rediscuss it with you guys. Else for tomorrow, as we said, so we're gonna have. I'm gonna update the link so that the link STC14/join will actually redirect to the good virtual room tomorrow. So you'll be able to use the very exact same sofaframework.org/stc14/join will guide you towards the good virtual room. There's going to be a coding sprint morning, and then the afternoon. I think if Christian same, you could. I don't know if you would be available from 1:30 to 3 here in the afternoon, where we would have the discussion with François, maybe Jeremy, hopefully Stefan as well, and I mean, as many of you can be involved here for making your wish list of what could be. What could actually get in SOFA, or what could become SOFA, or what we could do completely apart from SOFA, but something new. So basically even what could be this SOFA 2.0. We'll see where it leads in terms of discussion, and then there will be discussion on collision, and GPU development is really like for me a huge interrogation point, since for the moment we don't have much contribution on this topic anyway. But yeah. It would be the occasion to us, yeah.
So tomorrow, it's tomorrow, right? Huh?
Yeah, tomorrow, yeah.
I can be only there the first 30 minutes. So
okay. Anyway, so
I will give my wish list and.
Okay.
But I don't know, because you want to stop the discussion now, or?
I mean, if there is other topics to address, today is really like for roadmap topics. So if you want to like add things for the roadmap, do not hesitate. It's over here, but I think it's already like a lot for the roadmap. But if there is other topic to be discussed, we can definitely discuss it. Otherwise, that was about it for the program, in which is like following the every year or every 6 months actually program of the technical committee. Would you like to discuss something else, Christian?
No, it's okay. No, maybe we can. I mean, you can close, and maybe some of us can stay and discuss more on some topic.
Yeah. So yeah. Anyway, for the roadmap, I think we're gonna close that here. The meeting point, so the starting will be again. It's every day at 9. I try to make it actually pretty simple and clear for everyone that it's every morning at 9. So there will be again, as I said, the room that will be open, following the very same link as today, and yeah. So I'm gonna stop here the recording if I here can find the WebEx again, and see you tomorrow for the technical discussion, coding sprint, and so on.